Good morning, everybody. I'm so glad the sun is shining. We are getting started on quadratic functions or parabolas. And before we start, I want to just remind you of some of the forms of lines that we've already done. So if you can print this out, recall we have a few forms we've already done. One is linear. And whenever you see an equation that's linear, you're going to get y equals mx plus b. And then we also have exponential that we've talked about this year. And an exponential equation is y equals a times b raised to the x. And what we're going to do today for our learning goal is we're going to try to recognize the properties of quadratic functions and use them to create graphs. So if you have graph paper at home, that's really helpful. If not, I'm sure you could probably look for graph paper on the internet and print it off if you need it. So first thing we need to know, what is the standard form of a quadratic equation? Okay, quadratic equation looks like this. Y equals some number a times x squared plus b times x plus c. What makes it quadratic? The fact that it's raised to the second power here. So going back to our test from Friday, this would be called a quadratic because it's raised to the second power, trinomial because there's three terms. Now, in order to graph this, a quadratic equation is going to look like an upward shaped U or a downward shaped U shape. So we need to find the vertex. We need to find where this line changes direction, where it bottoms out or tops out. Here's the formula that we have to use to find the vertex. And it's going to be x equals the opposite of b, that's the number in front of the x, over 2 times a, which is the number in front of the x squared term. All right, once we find that, we're going to plug the x into the equation to find the y, and that's going to give us our vertex point. This is the vertex point here. And depending on what we find, it's going to be in the form x comma y with parentheses around it. And then we're going to have to make a little graph of it. And you do have to have at least 5 points when you do a parabola. We're going to choose, once we find the vertex, we're going to choose 2 points that are x values above the vertex and below the vertex. And what I usually do in my chart over here is I will star like the middle position, and that's my vertex. All right, so let's look at a equation and let's work it together. So let's say I gave you the equation y equals x squared plus 2x plus 4. What I like to do, but you don't have to, is I like to go then and list my a, b's, and c's below so that I know if I'm using a formula where I get my numbers from. All right, so step number 1, find the vertex. So what do? Opposite of b, which is 2, over 2 times a, which in this case is a 1 because there's nothing in front of the x squared variable or term. All right, so negative 2 over 2 is going to give me a negative 1. So my vertex, the x coordinate of the vertex is negative 1. All right, in order for me to find the y coordinate, I'm going to have to plug in negative 1 into my calculator and use this equation to get it done. Now remember, when you use your calculator, okay, you have to put a parenthesis around the negative sign. So I'm going to enter negative 1 inside parentheses, then use my x squared key. If you don't do that, it's going to give you a negative 1 as your answer. And when you take negative 1 times negative 1, you actually get a positive 1 for your answer. So be careful about the parentheses when you use your calculator. Okay, our value for b, let's see, negative 1 squared. That's what the x is. I'm going to do 2 times negative 1. Whoops. How about a plus? That might help. Plus 2 times negative 1. And then I'm going to go plus 4. So I'm just plugging in the x coordinate of the vertex into my equation. And what I get in the end is 3. All right, this point right here, negative 1, 3, is your vertex. So I'm going to plot it. I'm going to go 1 to the left and 3 up. This is my vertex. Okay. Now, we have to find a few things above and below this negative 1. So let's see here. I'm going to go values that are bigger because that's just easier. I'm going to put a 0 here and a 1 here, a negative 2 and a negative 3 here. All right, I'm going to go with 0. That's an easy one to work with. So if I put 0 squared plus 2 times 0 plus 4, I get 4. Okay, there is a second point on my parabola. So 0, which is on the y-axis, and up 1, 2, 3, 4. There's my next point. Now I'm going to put a 1 into my original equation right here. And I'm going to work it out. So 1 squared, and I know these are easy, but I'm just showing you guys how to use the calculator strokes so that it's pretty obvious. And my next point on my parabola is going to be 1, 7. 1 to the right, 1, 2, 3, 4, 5, 6, 7. All right. And then I'm going to trace that and put an arrow on the end because technically this does go forever. All right. Now, before we move on and do the negative 2 and the negative 3, I want to show you something. This is kind of cool. All parabolas are symmetric. So there's an axis of symmetry that goes through the vertex. And when you fold the parabola over that line, both sides will match. So axis of symmetry is very easy to find. It's going to be an x equals, because we're going to have a vertical line that goes up and down. And all you need to know is the x-coordinate of the vertex. So right here, I'm going to draw a dotted line. This is my axis of symmetry. Okay? And the easiest way to do this is, if you look at your axis of symmetry, you'll notice that the vertex is right on there. This point is 1 to the right. So if I go to the opposite side of that axis of symmetry line and make a point 1 to the left, I should get my y-coordinate for negative 2. This one right here, since it's symmetric, is 2 to the right of that line of symmetry. Now I'm going to go opposite side of the line of symmetry and go 2 to the left. All right, let's verify, because you can do it on the graph like this, and then check using algebra, or you can use the formula. So let's just check our formula and see if it matches with what I have here. So I'm going to put in a negative 2 for the x squared, so remember parentheses, okay, plus 2 times a negative 2 plus 4, and I get 4. What do you know? These two match. That checks for our symmetry. Are we at negative 2 and then 4 up? Yes, so we're good. Now let's check algebraically the point negative 3. Again, when you use your calculator, you're going to put it in with parentheses. So I'm going to put 2 times negative 3 plus 4. And I get a 7. And what do you know? Again, those match. So I'm going to continue to connect this, and here is my parabola. It's a U-shaped graph. It has symmetry around this purple line that I put in here. And we know the vertex and we know the axis of symmetry. Now, a couple of the things that you need to know. Domain and range. Technically speaking, the domain is my x values, anything that I can plug into my equation. And you know what? That is unlimited. That's going to be all real numbers. I can put anything in, and I should be okay. It's a little different for the range. If you look here on our graph, this thing bottoms out at y equals 1, y equals 3. If you look in the table, okay, all my values here are 3 or bigger. And that is going to be the case no matter what. So when I write my range, I'm going to have to say the y values that I get out when I plug in my x's are greater than or equal to 3. So all the numbers here, if I continued this pattern, went -4, +4, -5, +5, plugged it into my equation and figured out what the y was, I would continue to get numbers that are greater than or equal to 3 for my y column. Okay, so a little bit of a summary here. In a quadratic, ax of the form ax squared plus bx plus c, okay, the value of a is going to tell you if the parabola opens up. And if you look, that's what happened above. Okay, or down. Okay, how do I know before I even graph it if this parabola is going to be a U-shaped graph or if it's going to be an upside down graph and go down, an upside down U? Well, all I'm going to do is look at the a value, and if it's a positive, like in our example, this parabola will open up. Okay, if it's a negative, then this parabola is going to open down. So A is a really good indicator, and it should help you out with this. If you mess up on your negatives and plugging them into your calculator, you will get something different. And you should know if the number for, or the coefficient for the x squared key is positive, you need to have an upward shaped parabola.